Hello again. This is part of Pre-ACE Chemistry Chapter 0, all about working with scientific skills. So when you're in the lab, it's important that we know how to calibrate and read glassware. We went through calibration a little bit, but we will review that as well because a graduated cylinder is basically like a ruler, but vertical. So quick math review, we're going to do some quotient problems or division problems. If you have 10 pizzas, for 5 pizzas, you divide that by 10 by 5, you get just 2 because pizzas will cancel out. Unit on top, unit on bottom cancels out. Now if you take 10 pizzas divided by 5, 5 whatever, you would get 2 pizzas because units don't cancel out and there's no unit on the bottom. Now, if we change that to $5, so 10 pizzas per $5, that means $2, 2 pizzas per dollar, which is a pretty good deal. So now we know how quotient works. So for example, numerator divided by numerator and denominator are part of quotient. The units will cancel out if you have the same unit on top as on the bottom. For example, 6 centimeters per 2 centimeters equals just 3. That means basically 6 centimeters is 3 times bigger than 2 centimeters. And the same thing for 10 hot dogs divided by 2 hot dogs is 5. So 10 dogs is 5 times more than 2 dogs. Now if we have the unit on top with nothing on the bottom, the unit just carries over. So 12 B's per 2 is just 6 B's. But now if you have a numerator and denominator with different units, the units will carry over, but you gotta make sure you put that per sign. So 8 colas per 4 people means 2 Cokes per person, and 20 fish per 2 aquariums means you put 10 fish per aquarium. So a quick review on calibration. Remember, in a metric ruler, it's always 1 millimeter per space. So for example, this white piece of rectangle will go to 12.5, 12.6, and then you estimate that last number. So it's roughly maybe 12.64, 12.65 centimeters, because that's what rulers are measured in. So here, a quick example again. We have 2 lines, one at 10, one at 11, so it's 1 centimeter. There's 10 spaces, so it's always 0.1 centimeters per space. And that's for all metric rulers that you are going to use. Graduate cylinders. Graduates come in different sizes. You'll see 10, 50, 25, 100, 250, 500, even a liter. You always want to use the smallest graduate as you can without overfilling it. So if you have a measure 9 milliliters, you want to make sure you use a 10 milliliter graduate cylinder, not a 100 or a 50 or even 25. Always use the smallest that you can. Numbers on the graduate cylinder are just like a ruler. You calibrate the same way. They're always numbered in milliliters. So that 60 line is 60 milliliters, and 50 is 50 milliliters, and then the middle line is going to be 55. The meniscus. So water is polar, which means it basically concurves down, called a meniscus. So when you measure a graduate, you always measure the bottom of the meniscus, not the top, just the very, very bottom. So here, it's just below that little line right there. So basically it would be like 8.7879 milliliters. Calibration the same way. You take two numbers and you divide by how many spaces there are. So I took 50 and 60 divided by 10, that's subtracting is 10 divided by 10 spaces. So in this case, it's 1 milliliter per space. You can see the volume, the bottom of the meniscus is just underneath that 53. So it's going to be between 52 and 53. So we know that. And it's closer to the 3 line, so we're going to say 52.8 milliliters. So those 52 is a known number. Remember the term known. And then the 8 is an estimate. Again, it's approximation. If you said 7, that's fine. Even 9, that'd be fine. Again, it's approximate. So calibration, we have two numbers, 8 and 6. So that is 2 milliliters, and there's 10 spaces between them. So each space is 0.2. So knowing that information, you look at the meniscus. It's between 6.6 and 6.8. I would say closer to the 6.6 line. All right, other things that we can put liquids in, beakers and Erlenmeyer flask. On your paper, you're going to draw a sketch of those, but beakers are basically just to hold liquids, hot or cold. We don't use it to measure, we use it maybe approximate. So like if you need approximately 200 milliliters, you can use a beaker. It's easy to pour because there's a little spout at the end, at the side. Erlenmeyer flasks, mostly we just use it to, again, store liquid. Most of the time where we use it is for if we need to use it to hold a stopper, so you can fit something on top of it and hold it, or for titrations because it keeps the liquid from splattering, unlike a beaker. And the graduated cylinder, you always have numbers on the right side, always read those. Sometimes on the left they might go in opposite direction, but stay to the right, just like driving. On the right, beginning at 0, goes all the way up depending on increments, and the left ones go decreasing, so that's why you always want to stick to the right. Okay, so for accuracy, always use a graduated cylinder to measure volume. Always use the smallest graduate you can without refilling it. So if you want to measure 30 milliliters, you have to use a 50 milliliter graduated cylinder. 25 won't work. Okay, always read the bottom of the meniscus for the most accuracy. And that's it. So you will finish the worksheet given out in class to find the different measurements of the graduated cylinders.